In this lesson, we'll be exploring how to determine the range of a function. The range of a function is the set of y values for which a function is defined. Just like we have domain, which is the set of x values that makes a function defined. Let's start with graphing a function, which is a useful approach to understanding how to write the range of a function. If we have a linear function, for example, now a linear function, it's usually a straight line graph, which gives you the form, let's say f of x equal mx plus c, where c is the y-intercept, m is the slope. This means that the straight line graph is determined by two critical points, which is the slope, and one point on the line, which is the y-intercept. If we plot the graph of the straight line graph, we are going to have something of this nature. This arrow indicates continuity. We have negative infinity at this end as it extends to positive infinity. How do we write the range of this function? We'll say that the range is using set notation, that y is a set of all real numbers. Or we can write it in interval notation, that y is from negative infinity to positive infinity. You must start with the lowest, then to the highest. That is the way if you are writing in interval notation. Let's take another example. Given f of x equal 2x minus 3, find the range of the function. Now, how do you find the range? Now, in this question, we see that the slope is 2 and the y-intercept is minus 3. The slope determines the unit difference. Now let's take a table of this. Let's find the y values for given values of x, and that will guide us in plotting the straight line graph. Okay, so when x is 0, if we put replace x with 0 there, we are going to have 2 in 0 minus 3. So when x is 0, y is minus 3. Now when x is 1, let's see what will be the value of y. The same thing, if we replace x with 1 here, is going to be 2 minus 3. That will give us minus 1. When x is 2, let's see, y becomes 2 times 2, 4. 4 minus 3, that is 1. And when x is 3, y becomes 2 times 3 is 6, 6 minus 3, and that will give us 3. Let's plot this graph and see what we get. So when x is 0, right, which is at the origin, y is minus 3, y is minus 3, so we have minus 3 here. When x is 1, let's say 1 it's somewhere here, right, and y is minus 1, y is minus 1, meaning minus 1 it's somewhere here. Let's say minus 1 is somewhere here. And when x is 2, when x is 2, y is 1. Y is 1, so we'll take 1 to be somewhere here. When x is 3, y is 3. Y is 3. Now, if we join all of these points, this is what we are going to have. This is what we are going to have. We are going to have when x is 3 minus 3 is, sorry, when x is 0, y is minus 3, which is what we have here. When x is 1, y is minus 1. So this is the point here. So we have these, and when x is 2, y is 1, which is the point here. When x is 3, y is as well 3. Let's say our 3 for x is somewhere here. Y is also 3. We are going to have a straight line graph of this nature. And you see, this is continuity. Remember, this is continuous, meaning we have our negative infinity here, and we have our infinity as it extends upwards. How do we write the range then? Range is from negative infinity to positive infinity. This is in interval notation. You may as well choose to write it in set notation, meaning that the range, which is y, is a set of all real numbers. Remember, when you are writing in set notation, you use only the curly bracket, meaning y is a set of all real numbers. All real numbers begin from negative infinity to positive infinity. For the purpose of practice, the next example, try your hands on it and come back to the video when you are done. In this example, we are going to take a linear function with restricted domain. If we have, for example, f of x equal minus x plus 6 for 0 less than equal x and x less than equal 4. Find the range. Solution. In this example, you will notice that the function is negative, meaning that the line segment of the graph it's going to be inverse and it's not an infinite line. Let's take, for example, if we sketch the table of these function, we have the x and the y. Where x is 0, let's take the value of 0. If we impute 0 in that function, minus x plus 6, that's minus 0 plus 6, it's going to give us 6. So y is 6. When x is 4, then we do the same thing. Minus 4 plus 6 will give us, minus 4 plus 6 will give us 2. So y will be 2. Let's sketch the graph of these values. So when x is 0, y is 6. So let's take our 6 to be somewhere here, and our x, which is 0 from the origin, and x is 4. Let's take x to be 4. Let's take our 4 to be somewhere here. Y is 2. So our 2 will be somewhere here. All right, so this is the point. And if we draw the straight line, we are going to have something of this nature because it is inverse. How do we now write the range of these function? The range will give us that y, it's between 2 and 6. Or we may choose to write it in set notation, and that will mean that our y, remember in set notation, we use the curly bracket. Our y is a set of all real numbers, but y is between 2 and 4, so we are going to have 2 is less than equal y less than equal 4. And whichever way you can write it in either set notation or interval notation unless otherwise specified.